had. So, number 12. Do you know the first term in number 12? Do they tell us that?
Yes.
They tell us it's negative 3, right? We need to get the next 3 terms after that. Each time it says the first term is negative 3, and after that it is 4 less than the previous, which would mean the next one should be negative 7. Now, looking at number 12, are there other questions on how you're, so we got negative 7, we're going to go 4 more, or subtract 4, we should be at negative, okay? So, question 13, I didn't see up there, did 13 go okay?
Yeah.
So 9, how did you get, what does this thing right here mean? This thing right here, what does that mean when you have a to the n minus 1? Means, Elise, it means previous. This is telling us that if I'm going to find the second term, that I'm taking 2 times the previous term. And then I'm going to add 5. So when I think of that, my previous one, if this is my second, I have to take 2 times the first one, which was 9, and then add 5. That's what that means. A to the n minus 1 is just a shorthand way of writing the word previous. Do you not have yours? Yes. So, do we need to go through 13, or did that make sense? Because I had some people in during advisory with questions on that. So once I get this one, 18 plus 5, I should have had 23, right? To find the third term, I have to take 2 times the previous, which is 23, and add 5, okay? That's how you get the third one, and you can't find the fourth one until you found the third one, right? So if you didn't do that. If I'm looking at 14, 14 says the first one is 1. That's our given information. To find the second term, it says square the first one, previous squared. 1 squared plus 1. 1 squared is 1 plus 1, 2. So my second term is 2. What is my third term? A to the 3 means take the previous term, that's what this is telling us, and square it. So the previous is now 2 squared plus 1. 4 plus 1 gives me 5. So I'm not adding the same thing, it's giving me a different rule, right? This is 4 plus 1, that gives me 5. So I have 1, 2, 5. So if I'm asking you to find the next term, we're going to take a to the 4. What am I squaring, Hayden? What is the previous to the fourth term?
3.
My previous is the third term, but what is that previous number in my sequence up here?
26.
Okay, wait. Go to this problem, 14. Okay, so 1 is the first one. Quiet, please. 2 is our second one. So we use 2, which when I had 3 here, the previous one was 2, and I squared it and added 1, and I got my third term, which was 5. Okay. So to find the fourth one, I have to take the previous, the third term, which is 5. I'm going to square that and add 1. So I take 5 squared, which is 25, plus 1 gives me 26 for that term, okay? As I'm looking at those last ones, 15 says you do 3 of these puzzles, you increase your logical thinking skills. The sequence is S of n equals 3n. Give the number of puzzles when you're done in n weeks. How many puzzles will you complete in 8 weeks? So we are looking at S sub 8 equals 3 times 8. Should have had 24 if you were looking at that, right? If I'm looking at questions of the last couple ones, so we're not going to do all of those. Is there any ones? And notice it says recursive formula, so we're really focusing today on recursive. This is in your textbook. It's 4-7. If you're struggling with this, go to YouTube and put in recursive formulas, arithmetic sequences, and you're going to find a ton of things that are looking at that. Some get more complicated than what we're at, but you can look at those also. So we're going to be able to define it by a common difference in our I can statement. So you need to make sure you're looking for a common difference. We're always going to be determining that common difference between two terms. The common difference is really the slope. It's your rate of change. It's the change in y over the change in x, that common difference. It's how they are changing. We're going to be distinguishing between explicit and recursives a little more tomorrow than today, but today we're going to be using that recursive formula to generate the sequence and write recursive. So, recursive formulas are used to generate terms in a sequence by identifying where you start and how much you either add or subtract. So, if we think of it as kind of stepping up, you have your first number in the sequence, the second, the third, all the way up to, notice this says a to the n minus 1, and then an. This is always your previous one. So when you think about your equation, writing that rule, this is how you're writing the rule. It's always the a to the n minus 1, that is your previous term. And then it's plus the step up or the rate of change, the slope. So that step up, that's kind of like our slope that we did earlier in this unit. So those would be important to have on your notes that you are looking at that. Previous slope intercept at the top that we were looking at, that this is really that common difference is the same as our slope when we look at that. So arithmetic sequences, a lot of vocabulary in this part again. So some sequences are composed simply of random values, while others have a definite pattern that's used to arrive at sequence terms. Arithmetic sequences always follow repeated adding a constant, always the same amount, from one term to the next. The constant is called the common difference, usually represented by D, for difference. The common difference could be subtracted from the first term or it could be added, so when you're looking at that. So when we look at this, we can take our second term and take 4 minus 1 and say, oh, yeah, that common difference is 3, and I can see that I kept adding 3 on each one. It says all arithmetic sequences can be using piecewise equations, also known as a recursive formula. 2 parts. So when I look at this on the test and I ask you to write a recursive formula on our test next week, I'm going to be looking for the first part, then I'm going to look for a to the n, and I'm looking for the rule. And so this is always our rule, and you have to have when n is greater than 1, okay? Next page, let's look at writing the sum. So, first thing you want to do when we are looking at these different sequences with this notation is think about what this is telling us. So, we know if I wanted to list the first 5 terms, I know the first one already is negative 24, right? This is telling me that my rule is to take the previous and add 3. Which means if I am finding a sub 2, I am taking negative 24 and I'm adding 3, which gives me a negative 21. Okay? And so can you already tell the common difference? What was the common difference? What are we adding? We are adding 3. So they asked us to find the common difference. You want to tell me the difference is equal to, in your homework tonight, 3. That was this number right here, and it was a plus 3. So you don't have to put a plus 3 in front of it. You can just leave it as 3, but if it is a negative 3, if you're subtracting, you definitely want to keep the sign. So, do I need to maybe write these out anymore now that I know the common difference is each time I'm adding 3? I'm going to get negative 18. I'm going to have negative 15. So we got 4 terms at negative 12. And I'm going to put these dots behind here because it would keep going, right? It's a sequence. We've just listed the first 5 terms of it. Okay? So, what I want you to do on this next one, it says identify the common difference, so we want to think of what is our D, and then we are going to write a recursive formula. Do we already know our first term, Evan? Yeah. It is negative 5. Now we're going to be writing a rule, so I want you to write your common difference down right now on your paper. You need to check with someone, and then think about what our rule is each time, once you've looked at that common difference, to try and write your rule for n greater than 1. Okay? So I'm going to give you just this is our difference. If we are now writing it, Brody, what is our rule going to be?
A of n minus 1
Plus 10. For n greater than 1. That's it. That's all we are looking for when you're asked to write that. Okay? So as we get to that next part, we get a little harder in our equations as we were doing it. And it says, okay, recursive formulas describe where x is the term and y is the value of the term. So if we're looking at this, y equals negative 2x plus 3. So if you plug in 1 in that equation, okay, if I think of x equaling 1, what would we get? When x equals 1, y equals what? When x equals 1, y is equal to 1. Negative 2 times 1, right? Plus 3 would have been negative 2 plus 3 is 1. When x is 2, when x equals 2, you would have negative 1. When x is equal to 3, y would be equal to negative 3. What is our common difference? Where is that here? It's our slope, right? So if we are actually looking at this, we want to generate. So it says generate the actual sequence. The actual sequence would look like this, right? 1, negative 1, negative 3. Then we would add what? Negative 5, negative 7. So make this list, okay? Someone said, well, what about this 3? That's like the 0 term. That's not the first term. It's like before that. So it says use the sequence to write a recursive formula. So we would now say, Laura, a to the 1 equals 1. A to the n, Elise, is going to be equal to a to the, minus 2. Make sure you put 4n greater than 1. I have that when we do it, okay? So then I want you to write down this question that says this. I want you to write down, why is the first term 1, not 3? And what is the 3? So take a minute and write that question. Why is the first term 1, not 3? Because when x equals 1 in our equation, y equals negative 2 times the first term plus 3, it is equal to 1. So the 3 is called the 0 term or initial value. That is our y-intercept, but we're not going to use it in when we are looking at sequences. So you just got to be really careful for that. A to the 0 is the initial term, not the... How in the heck do we even start that? What are they asking you to do? So, most of you are probably thinking, I have no idea. So, what I want you to think of is that if we were going to write that sequence, we would have had the 7th number is negative 1, is negative 45, and the 11th. We want to write that as an ordered pair. So, we're going to say the term, which is the 7th term, and then what number is that 7th term, which is negative 45. So this is telling us the second ordered pair. 11, the 11th term is negative 69. Now, notice the first step says find the common difference or slope. You now have an ordered pair. So you go back to unit C1 of this unit, and this is our x1, y1. This is our x2, y2. And to find the slope, it's the difference of your y coordinates over your x coordinates. Does it matter if I start with negative 45 or negative 69? Mm-hmm. No, Lulu, which one are you starting with?
Negative 69.
Okay. Minus what?
Negative 45.
Okay. So that is going to become a plus when I look at that. Okay. And in our denominator, since I started with negative 69, Lulu, I must start with 11 minus 7. So first thing we have to do is find that slope, which gives us a negative 24 over 4 equals -6. That's my common difference. That's my D, right? My common difference is each time I'm going to be subtracting 6. So now we want to find the first term. Ooh, you want to be thinking point slope. So we're going back to the beginning of our unit. So point slope, Jack, what does general point slope form look like? Y equals what? M, that's slope intercept.
Oh,
Point slope. X minus
X
plus Y1. Okay, so looking at that, if we are looking at it, so Lizzie, which point do you want to use? The 7, -45, the 11, -69. It doesn't matter, we just got to choose one.
7 and -45.
So we are going to start with replacing M then with what, Benson?
So, wait, what?
So we got to get our slope.
So,
What was our slope? Our common
-6.
-6. Lizzie said we're going to use the 7, -45, so we're going to go X minus 7 or plus 7? Minus 7, good. Plus the -45.
Well, plus or
Does it matter if you have a minus 45 or plus negative? Shouldn't. So now we're going to look at this, and if we are looking at this, we have a couple of options. We can distribute this and say y is equal to what? -6x plus how much? -6 times -7 is going to give us 42. Okay, good.
-86.
Plus -45. So my new equation, -6x minus 3. I know my y-intercept is -3, right? What is my first term? So if x equals 1, what do I have to do in this equation to find my first term, now that I got this in slope-intercept form? Okay, so the x is going to be a 1, so tell me what to write down. So when you do your homework tonight, you're going to do problems like this, and they're hard like this, and they take a lot of time and thinking through it. So we're going to write down what? -6, this equation, okay? But instead of x, what are we going to put at x? Why? We want the first term, right? So here, our x was 7 when it was the 7th term. Here, x was 11 because it was the 11th term. We want the first term, so we're going to replace in this equation x with 1. So -6, we're going to put times 1 minus 3, which would give us, Christian, what? -9. So at this point, the first question, we found our common difference. It says find the first term. Our first term is equal to -9. Angus, we need to start writing a recursive formula. So we're going to start with our brackets, and you're going to tell me to write down what first?
A1 equals -7.
No.
Oh,
-9. Keep going, Colby. No. Caleb. Sorry. Caleb. A to the n.
equals A n minus 1
Common difference.
minus 6
6. 4.
greater than 1.
Or n greater than 1. Okay? You have to do all this work. So when you're looking at those ones in your homework, there's going to be some where they give you the ordered pair. And I saw a question over this way. Did you get your question answered?
No.
Okay.
I was wondering. Okay, so how you got positive 42. So even if the 7 was originally positive, do you make it negative now?
Because if the x1 is positive, it's always x minus the x1. and we can't have negative terms, right? Because we can't have negative terms in a sequence. But if you would have a point like -2, 3, when you plug in -2, it becomes x plus 2. But we can't have negative terms here.
Oh, okay.
So it's always going to be x minus whatever the x coordinate is.
So then it
Okay.
changes it to negative then?
Well,
Multiply
-6
it?
times -7
Oh, okay.
is positive. Yep. Yep. All right, so let's look at this one. It says you borrow $650. For a new laptop, you agree to pay your parents back $30 a month. A sub n, let this be the number of months you owed. At the beginning, initially, your initial amount is you owe them how much? $650. After the first month, so we're going to write this recursive formula. So first we want to complete the table. So we are now at 620. Keep going and fill your table in, please. Each month we are subtracting 30, right? So each month we are subtracting 30. As you continue to do that, do we definitely know our common difference?
Yeah.
So, in order to write a recursive formula, we need to know the common difference, which in this case is -30, right? We're going to write our recursive formula. Emma, want to start us off? A to the 1? No. Gotta go 620. Does it make sense to everyone? Why 620, not 650? 650 is a 0. We are always looking at the first term, okay? After I put that down, what am I going to have for a sub n? Yep. For n is greater than 1, as we are taking a look at that. So in your homework, you might be asked to fill in a table. Again, if you're looking at that table, you could subtract any of those if you are looking at it to find. So in this last one, Joel, want to read for us?
We have a 27-page paper to write for English class. Each night you write 3 pages. Write a recursive formula to describe the number of pages left to write after n nights.
So, Mr. Hallquist and Mrs. Ives is busy. They have nothing to do in their spare time. They'd love to create a 27-page paper. So, we are going to look at each night. They're going to tell you, you know what, this isn't due till this certain time. And each night you're going to write 3 pages. So first thing I want you to think about is, if we think about making a table of this, so we're going to write that recursive. So we have the nights, right? And we might want to think of, oh, how many pages are left? Okay? So on 0 night, when you were assigned it, how many pages did you have left to write? 27. But after the first day, you've taken some time and you've written your papers, you are down to 24, right? Second day, you're now down to 21. You might feel it's more manageable. It's still a lot, right? So, can we definitely tell our common difference? The common difference, if we are looking at this, is going to be common difference is -3, right? So, please try and write your recursive formula from that. Thinking about the page, thinking about the situation, and that common difference, okay? A to the 1 equals 24. I'm then going to have a to the n, and if I am looking at that, Emily, I'm going to have
A sub n equals a sub n minus 1 minus 3 or n greater than 1.
yes. Questions on writing.
Minute.
So you're just looking at that formula and substituting that in. Your homework tonight